Welcome to the foundation of our world. Today, we begin our high precision guide with the first 50 elements of the periodic table. I'm Adeesha. From the lightest gases to critical industrial metals, we'll examine each element's data and its vital role in modern technology. Let's start at number 1. Hydrogen. Atomic number 1. Discovered in 1766, it's the primary fuel for space exploration and silicon chip manufacturing. Helium. Atomic number 2. First detected in 1868. This noble gas is essential for cooling superconducting MRI magnets. Lithium. Atomic number 3. Found in 1817. It is the core component of modern rechargeable batteries and lightweight aerospace alloys. Beryllium, atomic number 4, identified in 1798, this stiff, lightweight metal is vital for precision gyroscopes and spacecraft structures. Boron, atomic number 5, found in 1808, it's used to create high-performance lab glass and as a critical dopant in computer chips. Carbon, atomic number 6. Known for millennia, it's the foundation of life and the basis for high-strength carbon fiber composites. Nitrogen, atomic number 7. Discovered in 1772, it makes up most of our air and is vital for agriculture and industrial cooling. Oxygen, atomic number 8. Identified in 1774, it's the breath of life and a primary agent in high-temperature steel production. Fluorine, atomic number 9. Isolated in 1886, this highly reactive element is used in uranium enrichment and dental healthcare. Neon, atomic number 10. Discovered in 1898, it's famous for the brilliant glow of city signage and high voltage sensors. Sodium, atomic number 11. Isolated in 1807, it lights our streets and acts as a key reagent in industrial chemistry. Magnesium, atomic number 12. Found in 1808, this versatile metal creates ultralight alloys for smartphones and vehicles. Aluminum, atomic number 13. Isolated in 1825, it's the bedrock of modern aviation and sustainable packaging. Silicon, atomic number 14. Identified in 1824, it is the foundation of the entire global computer and solar industries. Phosphorus, atomic number 15. Discovered in 1669, it's critical for global food production and advanced fire safety. Sulfur, atomic number 16. Known since antiquity, it's essential for creating sulfuric acid and industrial rubber vulcanization. Chlorine, atomic number 17. Identified in 1774, it's the primary agent for safe drinking water and plastics production. Argon, atomic number 18. Discovered in 1894, it protects high-temperature welding and shields delicate electronic manufacturing. Potassium, atomic number 19. Found in 1807, it's a critical nutrient for agriculture and vital for various chemical processes. Calcium, atomic number 20. Isolated in 1808, this reactive metal is essential for making cement and refining steel. Scandium, atomic number 21. Found in 1879, it's a rare transition metal used to strengthen high-performance aerospace parts. Titanium, atomic number 22. Identified in 1791, it's the standard for medical biocompatibility and high-strength jet engines. Vanadium, atomic number 23. Discovered in 1801, this hard metal makes the durable steel used in tools and engine parts. Chromium, atomic number 24. Identified in 1797, it gives stainless steel its shine and resistance to corrosion. Manganese, atomic number 25. Found in 1774, it's essential for making high-strength steel and modern alkaline batteries. Iron, atomic number 26. Known since antiquity, it's the workhorse of our infrastructure and the core of Earth's magnetic field. Cobalt, atomic number 27. Identified in 1735, it is critical for battery technology and heat-resistant superalloys. Nickel, atomic number 28. Discovered in 1751, it's used in stainless steel, rechargeable batteries, and aerospace alloys. Copper, atomic number 29. Used for thousands of years, its perfect conductivity keeps the world connected through electrical grids. Zinc, atomic number 30. Isolated in 1746, it protects our structures from rust and enables complex metal die casting. Gallium, atomic number 31. Found in 1875, it powers high-speed electronics, LEDs, and global 5G networks. Germanium, atomic number 32. Identified in 1886, this metalloid is essential for high-speed fiber optic data transmission. Arsenic, atomic number 33. Known for centuries, it is a key dopant in the semiconductors that drive our digital devices. Selenium, atomic number 34. Found in 1817, it's used in photocells and to remove impurities in high-end glass. Bromine, atomic number 35. Identified in 1826, it's a vital liquid halogen used in fire safety and sanitation. Krypton, atomic number 36. Discovered in 1898, this noble gas is used in high-intensity lighting and research lasers. Rubidium, atomic number 37. Found in 1861, it's used in highly accurate atomic clocks and night vision imaging. Strontium, atomic number 38. Identified in 1790, it gives fireworks their red color and helps produce strong ferrite magnets. Yttrium, atomic number 39, discovered in 1794. It's essential for high-temperature superconductors and laser technology. Zirconium, atomic number 40. Found in 1789, it's highly resistant to heat and corrosion, making it vital for nuclear reactors. Niobium, atomic number 41. Identified in 1801, it makes steel super strong for jet engines and particle accelerators. Molybdenum, atomic number 42. Found in 1778, it hardens steel for heavy-duty tools and industrial catalysts. Technetium, atomic number 43. Synthesized in 1937, it is the most used radioactive tracer in medical imaging today. Ruthenium, atomic number 44. Identified in 1844, this rare metal hardens electrical contacts and acts as a powerful catalyst. Rhodium, atomic number 45. Discovered in 1803, it reduces toxic emissions in cars and creates a brilliant finish on jewelry. Palladium, atomic number 46. Identified in 1803, it's essential for multi-layer ceramic capacitors in all our smartphones. Silver, atomic number 47. Known since antiquity, its unmatched conductivity is vital for high-end solar panels and electronics. Cadmium, atomic number 48. Found in 1817, it's used to protect aircraft components and in specialized battery tech. Indium, atomic number 49. Identified in 1863, this element enables the touch-sensitive screens we use every day. Antin, atomic number 50. Known for millennia, it remains the standard for electronic solder and next-gen green hydrogen production.